L'Hopital's rule, which is L'Hopital. He's a French dude. It's a way of dealing with limits, and specifically indeterminate forms of limits. It's been a while since we did limits. So indeterminate forms are if you get 0 over 0 or infinity over infinity. It's like those don't really reduce. Like they might be 1, but they might be 0, they might be infinity, they could be anything. And so up until today, we would do algebra tricks. Like factoring. In fact, I think there was one on the most recent test. We snuck in an old limit factoring problem. It was an easy one. Just factor and the limits or the factors cancel. Long ago, we also multiplied by conjugates, especially when square roots were involved. Those were some of the algebra tricks to handling limits. But today we're going to learn a calculus trick. And the good news is it's easier than the algebra trick. I don't know, which might seem weird, like algebra is supposed to be easier than calculus. But this calculus trick is really easy to use, and the guy that figured it out is L'Hopital. And so he gets to name the rule after himself because he discovered it or figured it out. Let's do some old limits just to remind ourselves what we're dealing with here. Limit as x goes to -1 of 2x squared minus 2 over x plus 1. What's the first attempt with every limit? Substitution. Like plug it in, see what happens. So 2 times -1 squared minus 2 over -1 plus 1. And this is usually what happens. What happens on this one? 0 over 0. So that doesn't work. That means we need to do something because that doesn't reduce. That's indeterminate. Because there's like rules conflicting here. Like 0 divided by anything is 0, but anything divided by 0 is infinity. But something divided by itself is 1. So like what is this thing? Do you recognize what we would try on this one? We could factor it. So if I take out a 2 and then factor what's left, the x plus 1s cancel. So this is one of our algebra tricks. So this isn't L'Hopital yet. This is just reminding you what we can do with algebra. Oh, there's not even a place to put it in the bottom anymore. So 2 times -1 minus 1 is -4. This was like one of the very, very first things we did in here. The first few weeks of calculus was limits. And so that's why we take a couple minutes to go all the way back. Example 2. Limit as x approaches infinity. As soon as you see that, before you even know what the limit is, there's a saying that goes with this limit that sometimes you over apply. Like you apply it other places, but it only applies when x goes to infinity. What's the saying? that I'm referencing? Yeah. Top no, bottom O equal co. Limit as x goes to infinity of 3x squared minus 1 over 2x squared plus 1. Well, if we plug in infinity, I mean, we already know the shortcut on this one, but if we plug in infinity, we would get infinity over infinity. What does that mean? Who knows? But if x goes to infinity, this is the top no, bottom O equal co situation. So again, that's only as x goes to infinity. So people they go crazy with the top no, bottom O equal co thing and sort of over apply it. When we say top, bottom equal, what are we talking about there? What are we comparing? The exponents. So they both have an x squared. So this is an equal co situation. So the limit is 3/2. Again, that's from our algebra tricks. That's not L'Hopital. All right, let's talk about L'Hopital's rule, because he can shortcut some of this and handle things that aren't that algebra rules won't even be able to handle. If the limit as x approaches a of f of x over g of x is indeterminate, meaning 0 over 0 or infinity over infinity, like I don't know how to reduce those, it's indeterminate. If that's the case, then that limit as x approaches a of f of x over g of x, again, it's indeterminate right now, but L'Hopital figured out that it was equal to the limit as x approaches a of f prime over g prime. Be careful, this is not the quotient rule, right? You're not taking the derivative of the whole thing. You're taking the derivative of the top and the derivative of the bottom separately. So it's easier than the quotient rule. So there's sort of two mistakes. Sometimes people will use this for the quotient rule. That would be wrong. Other times people go the other direction, and when they hit one of these problems, they use the quotient rule. Like, no, that's wrong as well. You only have to do the derivative of the top and the derivative of the bottom for L'Hopital to work. There is a little bit of a on the AP test, if you want to use L'Hopital, you have to say that, hey, this original limit is indeterminate, therefore I'm going to use L'Hopital. Okay? So a lot of times in here you guys are lazy, and appropriately so, when it comes to showing your work. Like you're like, I know what's next, let me skip 14 steps and give you the answer. And that's fine, usually. But for L'Hopital, you've got to say it's indeterminate, therefore I'm going to use L'Hopital. So I'll try to show you what that looks like as we do some examples. And I will be grading it that way as well on the test. So there will be people who get the right answers, and I'll take off 2 or 3 points because they didn't do it the right format, and they'll be mad at me, but this is your warning. Limit as x approaches 0 of e to the 3x minus 1 over x. All right. What's our first go on every limit problem? Substitution, and that's still the same thing here. So let's substitute 0 in. Be careful. I'm not going to put an equal sign yet, because I'm suspicious that this is 0 over 0, which doesn't really mean anything. So instead of an equal sign, I'm kind of just going to handle the top and the bottom separately. So e to the 3 times 0 minus 1. Let's see. E to the 0 is 1, and 1 minus 1 is 0. And if we plug in 0 for x, we get 0. So I'm real hesitant to write equals 0 over 0, because that means it doesn't equal anything. So I haven't put an equal sign in there. I've written 0 over 0 only to say, hey, that's indeterminate. Indeterminate. Therefore, the 3 dots in a triangle means therefore. So I'm still trying to be lazy and abbreviate. Right? I don't need to write out everything, but I do need to let the reader or the grader know I recognize that this is indeterminate, therefore I'm going to use L'Hopital's rule. So, some people go overboard and write out a paragraph explaining, the history of L'Hopital. Just shorten that up. Indeterminate, therefore L'Hopital. So, limit as x approaches 0. Now I can do the derivative separately, right? This isn't a quotient rule problem. It's better than that. What's the derivative of e to the 3x? Yep. E to the 3x times 3. The chain rule plus the exponent rule. And what's the derivative of x? 1. And so let's try our plug-in 0 again. Oh, once again, there's no place in the bottom to plug it in. 3e to the 3 times 0 over 1. E to the 0 is 1. So our answer is 3. We really like L'Hopital's rule because it's pretty easy to use. The only thing that complicates it is if one of those functions is a hard derivative, then L'Hopital's rule is hard. But usually we give you pretty straightforward functions, and so derivative top, derivative bottom, substitute, there's your answer.
If the question specifically asks use L'Hopital's rule, do we still have to specify that we're using L'Hopital's rule? Yes. The question was if the question specifically says use L'Hopital's rule, do I need to say I'm using L'Hopital's rule? Because clearly you asked me to. So I get that. I want you to say it anyway because the AP test is not going to say use L'Hopital's rule. It's going to want you to know that you need to use L'Hopital's rule. Let's do one more. Limit as x approaches negative infinity of x squared over e to the negative x. Well, job one is always substitute. See what happens. So negative infinity squared, that would be positive infinity. Again, I'm hesitant to put the equal signs on yet. E to the negative infinity, that would be e to the positive infinity, which would be a really big number. So indeterminate, therefore we'll use L'Hopital's rule. Again, 0 over 0, infinity over infinity, doesn't work. Use L'Hopital. So derivative of the top. Pick on some people today. Tierney, what's the derivative of x squared? 2x.
Dia, what's the derivative of e to the negative x? Good. E to the negative x times chain rule -1. All right, so let's plug in now and see what we get. So 2 times -infinity, that would be -infinity. -1 times e to the negative infinity. That would be -infinity. Dang it, that's not good either, right? We're still indeterminate. So here's the good news. We can try L'Hopital's again. And you might catch what's going on here. By using L'Hopital's, especially if there's a polynomial in there, we went from x squared to 2x. So if we do the derivative one more time, Andrew, what's the derivative of 2x? 2. And Emma, what's the derivative of, you get the one with all the negative signs in it, what's the derivative of -e to the negative x? It is going to be e to the negative x, yes. All the other negative signs cancel each other out. So, plug in again. 2 over e to the infinity. Okay, that's not indeterminate, right? There's an infinity involved, but it's not indeterminate because what's 2 divided by infinity? This is the old, if I have $2 in my pocket and I want to divide it up equally among everybody in the whole world, how much money does each person get? Basically none, especially if there was infinite people. 2 divided by infinity is 0. So that's a good one for a couple reasons. One is sometimes you have to use L'Hopital's multiple times. Hint, the bonus on the test is a 2-step L'Hopital problem with another wrinkle thrown in, but it's a 2-step L'Hopital problem. The other reason I show you that is to remind you that just because an infinity shows up, that doesn't mean it's indeterminate. 2 divided by infinity, that's a number. That's 0. So that does have an answer. All right, I have a worksheet for you with L'Hopital stuff on it. I'll also give you a very short review. And then tomorrow we'll go over L'Hopital's worksheet, plus the review, plus any more from the big packet with all the pretty pictures on it. And so hopefully we'll be okay by the time the test rolls around on block day.